Hey, what's up, guys? So let's get going. We're doing the first semester exam review number 1 through 5. We're doing all of them. Let's hop right into it. So, first question here: what type of transformation is defined by this rule? X comma y goes to x comma y minus 3. So if you notice, the x stays exactly the same, so nothing is happening to the x value. It stays the same, but the y value here is getting subtracted by 3. Anytime you're simply adding or subtracting to something, we call this a translation. If you wanted to know for yourself, just so you can get it done, I'm going to go ahead and focus this camera because it keeps on zooming in and out. All right, cool. All right, so we have that minus 3. This is effectively a translation 3 units down, we would say. And if you are trying to, can you read what I wrote? 3 units down. So if you're trying to get notes going for yourself, we do want to think about how if we have like X, and usually what we're going to be writing is something about like the letter H. So X plus H comma Y plus K. I don't know why H and K are used for X and Y, but they always are. So H is going to be our left and right movement, and that says left and right movement. Sorry about that. And our K, just so I can scroll the paper down there, our K is going to be our up and down movement. And for these particular questions, they do exactly what you expect them to do. A positive on the y is going to move you up. A negative on the y is going to move you down. A positive on the x is going to move you to the right. A negative on the x is going to move you to the left. All right, let's hop into the next question. What is the component form of the vector that maps tu to t prime u prime? So you are going from this thing on the right here to the one on the left. So we typically talk about our left and right first, and then our up and down second, our x comma y. So we're just going to go ahead and count 1, 2, 3, 4. So we're going to the left 4 units. And then we're going to go down 1, 2, going down 2 units. So this is going to be our x value, and this is going to be our y value, just like before. So left 4, down 2, that is letter C. Next one, question number 3. For this one here, if our triangle ABC is congruent to DEF, the main idea when you're writing these congruency symbols is the position. So this is position 1, so A is the same as position 1 here, which is D. Then position 2 is the same as E. Position 3, same as letter F. Which side is congruent to DF? So DF is in position 1 and position 3 here. So likewise, for our other one is going to be A and C. So we're looking for either AC or CA. Looks like letter B is correct. Our next one here, so if x comma y goes to negative y comma x, where does this one get mapped to? So the main concept is that your x here is going to become the y value. So when we're rewriting our negative 5 comma negative 4, the x value is going to become the new y value. So there was our x moving to our new value there. So let me just write that right above it. Let's do x comma y goes to, and we negative y comma x. So again, our x value became the y value. And then over here, the old y value, negative 4, becomes the x value, but it has another negative in front of it. A negative of a negative is a positive. So that's a big idea there. A negative of a negative is a positive. So 4 comma negative 5 is our correct final answer to this question. Move on to question number 5. Here we go. So, what portion of a line that starts at a point? Oh, I'm going to pause for a second. I'm going to sneeze. Saved you guys a huge sneeze there. All right, what is a portion of a line that starts at a point, the end point, and continues on forever in one direction called? So, I'm just going to go, there's our point right there, right? Here's a ray going on like that. If you're looking for what a line is, a line would look like this one. And a line segment, big difference there, has the 2 dots at the end. We want the one that starts at an end point and continues in one direction forever. That is a ray. All right. What does the intersection of two coplanar lines form? So as a reminder, the word plane kind of in the middle there, I guess I don't know, plana, but the idea is this is kind of like your piece of paper. So just a reminder, it's kind of like our piece of paper, but it extends infinitely in both directions, or all directions, not just both directions, all directions. So it's kind of like a piece of paper. So it says, and then the word co means kind of on the same. on the same. So the idea is, what does the intersection of two lines that are on the same piece of paper form? So you drew two lines. Remember that lines have the arrows going off. Where do they intersect? They will intersect at a point. There you go. What is an angle whose measure is greater than 90 and less than 180? Well, that's obtuse. Pretty straightforward. If you forgot some of these other definitions, remember that a right angle is like this and is always exactly 90 degrees. A straight angle is like this and is always 180 degrees. And an acute angle is like this and is less than 90 degrees. There you go. The next one here. What type of transformation slides an image? Sliding an image is going to be a translation. For A comma B has its endpoints. Pausing for a second. I've already had to pause 3 times. Not even done with this thing. Let's get going here. All right, so we are finishing up number 9. If AB has endpoints at -4, 7, and B is this, use this distance formula to find the length to the nearest unit. So I personally recommend, just to make sure you're getting these questions right, that you actually fill in the formula kind of on your paper before you plug it into your calculator so you can see it at every single step of the way. You don't necessarily have to do that, but I think it's a good idea. So I'm going to go ahead and relabel this one. This is our first x value. This is our first y value. This is our second x value. This is our second y value. And from there, we're going to plug it directly into our formula. So we're plugging it directly in, and we have our 8 is our second x value minus -4 is our first x value squared plus quantity. We have y2, that is 2, minus y1, that's 7, quantity squared. And now we're ready to plug it into our calculator. We're going to do everything exactly as it appears that we wrote down. So in order to do that, when you're on your calculator here, you want to find the square root button is right here in blue. So to activate any of the blue ones, we're going to hit the second button and then the square root button. And as you can see, a beautiful little square root shows up, and we're going to make it go exactly as it appears. Our parenthesis is above the number 8, and we'll keep on going from there. We have 8 minus -4. Please note, when I wrote that in, we wrote minus -4. We used the big negative sign for the first subtraction and the small negative sign for the second one. And that is kind of the reason why I wrote it the way I did. Big negative sign, small negative sign when you're doing it. Parentheses squared plus, and then 2 minus 7 and the parentheses squared. We plug all that in, we get exactly 13. Please note, if you were trying to be a superstar student, being ready to go, you might have noticed this is kind of like 8 plus 4, and that's going to give you 12. And 2 minus 7 is going to give you -5, but you're kind of squaring it, which means that you could have gone for the 5, 12, 13 triangle to memorize there. So if you did have that one memorized, could be useful because you didn't have to actually type it in the calculator. You could have noticed that you had the 5 and the 12. Distance formula really is just Pythagorean theorem. If you want to remind yourself the other ones that you should try to memorize for yourself, it is a 3, 4, 5 triangle, the 5, 12, 13 triangle, the 7, 24, 25, the 8, 15, 17, and our last one, 9, 40, 41. And I said last one, it's the last one you kind of could be using to memorize. There are an infinite number of them, but we only typically see like the first 2 really on those standardized tests and whatnot. Let's move on to the next page. Here we go for question number 10. So if AB has these endpoints at -4 and 12, use this midpoint formula. One of the big ideas with this midpoint formula is you want to have 2 separate things. So I'll go ahead and fill in our x1, y1, x2, y2. When I say 2 separate things, you're not plugging this entire thing into the calculator at once. It'll throw you an error if you even attempt it. So instead, we're going to write down our very first x value. First, just the x value. So I'll be more clear about that. The x value is just the x part of it, and that's going to be our -4 plus 8 divided by 2. And we could plug this into the calculator here. So plugging into our calculator will require us to use, for a fraction, we're going to hit alpha y equals, and then enter. If you hit those buttons in that order, alpha, y equals, and enter, you will get a beautiful little fraction. We're talking about this green alpha button right there. And then you're going to hit the y equals button, top left-hand corner, and then finally the enter button in the bottom right-hand corner. If you hit those 3 buttons in order, you will get a beautiful little fraction that didn't even show up when I said there would be. All right, well, now there is one. Okay, so alpha, y equals, enter, and from there you type it in exactly as we wrote it down. So we wrote down -4 plus 8 divided by 2, so -4 plus 8. You did have to use that small negative sign, and we will get 2. However, I don't think you actually needed the calculator to do this question because -4 plus 8 is the same thing as 8 minus 4. 8 minus 4 is 4. Divided by 2 is 2. Likewise, we could do the same exact thing for the y value. The y value is y1 plus y2 divided by 2 from that formula right up there. And we're looking at 12 plus 2 divided by 2. We could, again, I think, do this without a calculator. 12 plus 2 is 14. 14 divided by 2 is 7. So our final answer is 2, 7. Nice and easy. Number 11, we did not go over this one during class nearly as much as we should have because it's actually going to be a semester number 2 topic. We're teaching it in January. So the idea of a rigid motion, what that means by definition is creates congruent figures. If you want to think about rigid, usually like a fence is rigid because it won't break or something. You know, something steel is rigid, it won't break. Creates rigid motion, congruent figures, creates exactly the same figure. The only one that does not create congruent figure is going to be dilation. Again, we didn't actually learn dilation. Don't worry about it. We'll cover it in semester number 2. Number 12, describe the transformation that takes one from the other. So if you notice, this one is being flipped upside down. When you flip something upside down, we call that a reflection. And there we go. We finished our very first review thing. Let's go on to review number 2. So for review number 2, we're starting off with this question about use the figure where measure of angle 1 is 3x. Let's go ahead and fill that one in. And the measure of number 2 is going to be a 2x. We'll fill that one in. And we have to go ahead and use this to answer questions 1 through 3. All right, what is another name for angle 1? So angle 1 is this one right here. We can notice there's the letter C, but you can't use just the C because you don't know if it refers to angle 1 or angle 2. So you must use 3 letters. You always want to have the vertex in the middle, so we have to have C. So this one, the correct answers for this would have been angle ACD, which is actually the correct final answer, but the other way you could have written it would have been DCA. So that was an other acceptable answer for angle 1. Continuing on, what is the measure of angle 2? To find the measure of angle 2, I think it's going to be easiest to remember the idea that these two angles form what is called a linear pair. The idea of a linear pair, the word pair is 2. The word linear is on a line or like a line. So 2 on a line. These two are on a line. If they're on a line, the two angles will add to 180 degrees. So 3x plus 2x is equal to 180 degrees. 3 plus 2 is equal to 5. And if I divide both sides by 5, I will in fact get 36. However, don't be tricked. That's not the final answer to the question because the measure of angle 2 is 2 times x. So the measure of angle 2 is 2 times x, which is 2 multiplied by 36, which is 72. And there we go. To find the measure of angle 1, you have two options. Either A, you could plug in your 36 into x right here, or I think the easier option is to use that same linear pair idea and simply subtract angle number 2. So our measure of angle number 1 is going to be 180 degrees minus the measure of angle 2, which we found out earlier was 72 degrees, and we're going to get a nice 108 degrees. Cool beans. Moving on to the next page. For this one, use the figure to answer questions 4 and 5. What is the value of x? So these are also going to be a linear pair situation. All we have to do to say what the x is going to be 180 minus that 128, and that is going to be a nice little 52 degrees. And anytime you have two angles that are across from each other like this, these two are guaranteed to be the same, and these two are guaranteed to be the same. Anytime that you have these exact same angles that are guaranteed like this, we call these vertical angles. Vertical angles are identical, so x and y, x was 52, that means that y is also 52. Continuing on here, which use the figure to answer number 6 through 8. I think here's a great time to take some notes just in case you forgot what these things are. We learned 4 different terms. We could have learned a 5th one that's almost the same thing, but we learned quite a few of them. We learned, for instance, when these two are parallel and we have a line that goes through, this line here is called the transversal. Transversal, sorry about that, Transversal, transversal. The transversal is the line that goes through two other lines. And when the transversal cuts two parallel lines, it creates a couple of words that we are supposed to learn. One of the first words that we learned shows that if the measure of angle 3 is always the same as the measure of angle 5, so that this one here is the same as this one, and likewise the measure of angle 4 is the same as the measure of angle 6. So these two are the same and these two are the same, and those two, when we say that they're the same, our word is alternate interior angles. Alternate interior angles. The idea is they're on alternate sides of the transversals. They're on different sides, but they're in between the two lines, so they're in the interior. Likewise, we can also learn about alternate exterior angles. So alternate exterior angles are on opposite sides of the transversal, but also on the outside of the line. So number 1 and number 7. So we'll say the measure of angle number 1 is the same as the measure of angle 7, and likewise the measure of angle 2 is the same as the measure of angle 8, and again these are called alternate exterior angles. There we go. The other ones that we learned are going to be the ones that are on the same side. So for instance, 4 and 5 are on the same side of the transversal, and they're also in between. And because of that, these aren't equal to each other, but instead together add to 180. They're supplementary, we say. So measure of angle 4 plus the measure of angle 5 is equal to 180 degrees. And likewise, the measure of angle 3 plus the measure of angle 6 is also equal to 180 degrees. And when those things are true, we call these ones same side interior angles. Same side interior. Technically, there's also same side exterior, but for one reason or another, it's not technically on the curriculum, so we didn't put there. But if you wanted just to know for yourself, 1 and 8 would be same side exterior, and 2 and 7 would be same side exterior, and they also add up to 180. The very last one that we want to learn are the ones that are in the quote-unquote same position. So for instance, numbers 1 and number 5 are both in the top left-hand corner. Numbers 2 and number 6 are both in the top right-hand corner. Numbers 3 and number 7 are in the bottom right-hand corner. And numbers 4 and number 8 are in the bottom left-hand corner. So let's go ahead and fill those in. The measure of angle number 1 is the same as the measure of angle number 5. The measure of angle number 2 is the same as the measure of angle number 6. The measure of angle 3 is the same as the measure of angle number 7, and the measure of angle 4 is the same as the measure of angle number 8. And all of those ones together, we say that these are called corresponding angles. And again, they're corresponding because they're in the same exact position, and they're always going to be equal to each other. So we've written all this information down. Technically, you don't need all this stuff for this problem, but it's good to have a reminder of the review of like what we learned throughout the year, so you can use these words intelligently in the future when you need to. Which angle is congruent to angle number 5? Well, right up above, right away, we said the angle number 3 is because it is alternate interior angles. So that's going to be letter D. And number 7, if measure of angle 4 is equal to 40, the measure of angle 8 is what? Well, down here we wrote that 4 and 8 are the same exact thing. So this one also must be letter A. And for 4 and 5, we wrote right here 4 and 5 that they add to 180. So all we have to do is do 180 minus the 40, and that's going to give us our 140 as our correct answer. Let's move on to the next page of this one. So for our very next page, we are looking at question number 9 here. So question number 9, it says, what is the length of AB? So to figure out the length of AB, we will have to remember that it does tell us about these two congruent triangles. So we have like the position 1 and the position 2 is the same as this position 1 and this position 2. So we're looking that AB, this one right here, is the same as DE, that one right there. Luckily for us, they have already been marked up with our little information, the 4x plus 14 and the 6x. So we can go ahead and start solving our equation. 4x plus 14 is equal to 6x. When you're solving equations like this, we're going to go ahead and subtract 4x on both sides. When you subtract 4x on both sides of the equation, 6x minus 4x is 2x. And then we're going to divide both sides by 2, and we will get 7. And don't be tricked yet again, even though 7 is an answer choice, it's not what the question asks. It wants to know what is the length of AB. To write that down, we're going to say AB is equal to 4 multiplied by the 7 that we just figured out, plus 14. So we're slotting that 7 in. If you throw that into a calculator or just do it in your head, you will get 42. Moving on to our very next question, what is the measure of angle letter D? So the measure of angle letter D, we do have to notice again, we are in that first position. We're in that first position, the letter A, the letter D. So we're looking at this one here. The letter A and the letter D are both the same. So that means that 3y plus 21 must, oh, you can't even read what I'm writing. 3y plus 21 must in fact be equal to this 6y plus 3. Solving this equation, this is a great chance for that switcheroo. That 6y will stay in the same spot, and this 21 will stay in the same place, but that 3y will become a minus 3y over here. That 3 will become a negative 3 over here. And we go ahead and do this problem from there. 21 minus 3 is 18. 6 minus 3 is 3. Divide both sides by 3 and you will get 6, but that is not your final answer because you do need to plug it into the measure of angle D. So the measure of angle D in the original question was 6 times y, which we just figured out was 6, plus the 3, and that's going to give you 39 for our final answer. Pausing real quick. Here we go, question number 11. Given that triangle CPW is congruent to BHM, which statement must be true? So this one we're going to have to kind of go through one by one and notice our positions. So C and P is going to be positions 1 and 2. B and M is positions 1 and 3. So that one's not correct. PW here, that's going to be our second and third position. So it would have to be the same as HM, but it's not. That one's positions 1 and 2. So that one's not correct. Looking at letter C, CW, that's the first and the third, equivalent to BM, that's the first and the third. So that is going to be our correct answer. Another way you could have approached this question was to look over at the actual figure. It's telling you which ones were the same. So like C and P is the same as BH, and that's the reason why A is wrong. That H and M is the same as P and W, and that's why this one's wrong. But CW, which is the blank one, which we could put a triple tick mark on, right? Because they said they were congruent. That CW is the same as BM. Anyways, figured you guys might want to see another version of it. So number 12, for the triangle shown below, which theorem shows these two triangles are the same? I think it's important to mark up the angles and the sides kind of in the order, and then it makes it more obvious of which question is the correct answer. So if you notice, I'm going to go ahead and put an angle there, and then a side there, and then an angle there, because those are the ones that are marked on the figure. I didn't put an angle up there because it's not marked. I didn't put a side or a side there because those aren't marked. Likewise, over here, I'm going to go ahead and put an angle and then a side there and then an angle there. And I think that once you've drawn both of these up, it's super duper obvious that it's angle, side, angle on both of these triangles. For this last question, which one of these is needed to show that we have these two triangles the same by side angle, side congruence? So the angle must be in between the two sides. So here are two sides that are marked as the same. The angle that is in between them is this one. These are the two sides that are marked the same. So the angles that are between are this one. And now we have our side, our angle, our side. And again, if we use our letters like we did last time, the side, angle, side, we would see that we do in fact have that side, angle, side. Which angle did we actually say? The angle A and the angle E. That is letter D. Boom, boom, boom. Let's go on to the very next page. Here we go. So question number 1, it gives us this beautiful little formula for us. We don't even have to memorize our formula. How nice of them. If the sum of the interior angles in a polygon is n minus 2 times 180, what is the sum of the interior angles in a 10-sided polygon? All we have to do is throw in a 10 into our formula. So we're going to have 10 minus 2 multiplied by 180. And by the way, we can type this into our calculator exactly as it appears with the parentheses and all. 10 minus 2, 180. Boom, tells us it's 1440. Easy question for sure. Boom, boom, boom. Number 2, one of the main ideas on this question is remembering that there is a triangle rule. The triangle rule says that the exterior angle of one side is the same as the other two interior angles added together. That is to say, for this problem, 25 plus 92 is equal to x, and that is all you have to do. Just add those two numbers up, and 25 and 92 turns out to be 117. If you want to know why that is a true statement, you can think about it here, that this must be 180 minus the x value, but this angle would also be 180 minus these two, so x must be the same as these two added together. Over here, we have 3 different words, only in A, B, C, because there's only 3 possibilities. So scalene means all different. Isosceles means 2 the same, 1 different. And equilateral means 3 same. Because we have 6, 8, 10, all those are different. That's a scalene triangle. Here we go, number 4. What is the angle in the smallest triangle below? So the way that I like to say it is that it's visually it is the opposites. Like this 14 goes with the opposite angle out there. So that's one way of imagining it. You can also imagine it from the angles perspective, that like for instance, if I went from this letter A, we could go out the opposite direction towards it. That's one way, is just like drawing. So like it's drawn opposite is one way of remembering where these things are. However, if that doesn't work for you, you can also think the angle goes with the side of the letters it does not touch. Angle goes with side it does not touch. So what do I mean by that? So for instance, the angle A goes with BC. BC, because it doesn't touch those two. Likewise, the angle B, that one is going to go with AC. And last but not least, angle C must go with, in fact, AB. So you can either do it the drawn the opposite way I was just saying before, or you could say with the English version of it, the angle goes with the side it does not touch. Regardless, you're looking at the smallest angle. So the smallest side is number 14. So that's the AB. AB goes with angle C. That is the smallest angle, guaranteed. Moving on to question number 5. Which quadrilateral has congruent diagonals? My personal opinion when you're looking at questions like this is you have your quadrilateral packet out. I don't have one with me right now, but the main idea here is your quadrilateral packet has all the information you could possibly need about it. So which one of these has congruent diagonals? Well, a square does, isosceles trapezoid does, a rectangle does, so D, all of the above is true. All of these guys have congruent diagonals. And again, have that quadrilateral packet out and ready to go for that actual exam. Question number 6, which statement is not true of all parallelograms? So which one's not true? Opposite sides are congruent. No, that one is true. That is a true statement. This is true. True. Opposite angles are congruent. This one is also a true statement. Diagonals bisect each other. That is a true statement. So it's got to be letter D. Diagonals are perpendicular. This one is true only for rhombus. Don't forget, squares are a type of rhombus, so it's also true for squares. And also, diagonals are perpendicular for kites. However, this is a parallelogram, not a kite. Which statement is true for all trapezoids? So opposite angles are always congruent. In fact, completely false. Opposite angles are never congruent for trapezoids. That's just like total nonsense. Opposite sides are always congruent. Also total nonsense. That's a parallelogram. So those are both parallelogram rules. Exactly one pair of opposite sides parallel. That, boom, always is true. Diagonals do not have to be congruent. They could be. So letter B is what we're looking at for question number 7. And again, I'm just going to repeat it. You want to have that quadrilaterals packet out and ready to go for this test. All right, moving on to our next couple problems here. Question number 8, which choice completes the theorem? If diagonals of a quadrilateral bisect each other, then, so diagonals bisect, that is going to be a parallelogram. And again, have that information out in front of you. I don't know why it's drawn up for you, but I guess it kind of helps you. It looks like a parallelogram, right? I guess you don't really need this little picture that I'm blocking with my face, but you know, whatever. If ABCD is a parallelogram with AC is equal to 12, what is AE? Okay, so I guess that's what this one's referring to, this problem up there. All right, so AC is equal to 12. So here we go. You're told that this entire length is 12. And it wants to know what is AE. So the idea here is that these two are the same. So if the whole thing is 12, like the whole length is 12, then you can divide by 2 to get 6. So I may put like this is 12 divided by 2 is 6. I don't know, something like that. Because you're dividing it in half. They're both exactly the same. AC is the whole length. AE is half the length. I'm done talking. All right, number 10. What must be true about the diagonals in order for quadrilateral STUV to be a rhombus? Well, just like we said on the previous page, for a rhombus, the diagonals are perpendicular to each other. So they are perpendicular, so that's letters A and C. What are the other ones? They must be perpendicular and congruent. No, perpendicular and congruent diagonals is for a rectangle. The bisecting each other is the one that we want. If they were perpendicular and congruent, that actually makes it a square, because then it would be having the conditions for a rhombus and a rectangle, making it a square. All right, question number 11. If FGHI is a rectangle and FJ is 9, so that's a 9, by the way, for a rectangle. Anytime it says that it's a rectangle here, every single diagonal is guaranteed, or every single half diagonal is the same, and all diagonals are the same too. Wants to know what GI is. Clearly, 9 plus 9 gives you 18. Should be an easy enough one. Let's move on to the next one. Number 12. Which one is a false statement? A quadrilateral perpendicular diagonals must be a parallelogram. No, could be a kite. Could be a kite. Oh, so we're done right away, right? That is a false statement. Okay. Well, I guess we can just read through the other ones, making sure it's a true statement. Quadrilateral with two pairs of opposite sides parallel must be a parallelogram. That is a true statement. Quadrilateral with two pairs of opposite sides congruent must be a parallelogram. That's a true statement. Opposite, yep, two congruent angles. Opposite, boom, we're done. All right, which quadrilateral has two pairs of adjacent sides congruent? Two pairs of adjacent sides congruent. We say it is a kite. Technically, a square also makes that true statement, but kite also works. Same with a rhombus, but kite, yes, is the answer we want to. So I guess rhombus is there. All four sides are whatever. I'm going to say kite is the one that we want here. I'm done talking. Here we go. Moving on. We're on to number 4. All right. So you're told this is an isosceles trapezoid. One of the big rules for an isosceles trapezoid is that this angle is the same as this angle, and this angle here is the same as this angle here. And also for trapezoids, because they have parallel on the top and bottom, next door neighbor angles are going to add to 180. So for instance, this one right here must be 180 minus 144, which is 36 degrees. Anyways, which question do we want? Measure of angle H. We just said that one's 36. That one's the same as this one, so 36. We're done. That was an easy question, filled in already. Number 2, given the kite using the Pythagorean theorem, a squared plus b squared equals c squared, define BC. So for all of these ones, I will recommend to you one more time the same exact thing that I did before. We should always be trying to use our Pythagorean triples if we're able to remember them. On this particular one, we're looking for BC, so we want to figure out what this length is. We have an 8 and a 15. If you remembered it, we had 8 squared plus 15 squared equals c squared, and you might all remember from earlier in the video, I wrote down 8, 15, 17 as our final answer. So we actually already know in advance this is an 8, 15, 17 triangle. However, if you couldn't remember that, to finish off the question, 8 squared is going to be 64, 15 squared is 225, 64 and 225 is 289. Feel free to use your calculator while you're doing this. By the way, the square button, if you're doing it right here, square button is right there on the calculator. So for instance, if I just typed in something like, I don't know, 8 squared, and tell me that's 64. That's where I got those two things. Then we're adding these together. Afterwards, we're going to go ahead and take the square root of both sides of the equation. If you take the square root of both sides, you get the square root of 289 is equal to c, but the square root of 289, again, using that calculator, if you need to know where the square root button is, the square root button is in blue right here. So we're going to hit second square root 289, and sure enough, we get that 17 answer that we already wrote down as correct. But that's how you would do the long version. If you wanted to know as an additional practice, we could know that this is a 6, 8, and if I want to know what this one was up here, what AB is, we would say that AB is found by doing 6 squared plus 8 squared equals c squared this time. So a slightly different version of it. Doing all this work one more time, 36 plus 64 is equal to c squared, 100 equals c squared, the square root of 100 equals c squared, and the square root of 100 is in fact 10. But the way you could have done this in my fast way, if you remembered it, is that you have 6, 8, something that we don't know, but both 6 and 8 are divisible by 2. So we'd have a 3 and a 4, but from our previously written down information, that is a 3, 4, 5 triangle. We divided by 2 going this way. We're going to multiply by 2 going that way, and we're going to get 10, and that's the fast way to figure out that 10. I'm done talking. We're moving on to question 3. If ABCD is a kite, what is the measure of angle B? The big idea is for a kite, where the two not congruent sides meet, both of these have exactly the same value. So this one is the same as this one. Let's go ahead and give it the value x. That way, if we give it the value x, we can set up a beautiful little equation. We could set up 75 plus x plus 15 plus x is equal to 360, because all quadrilaterals, all four-sided figures, have 360 degrees in their interior. So 75 plus 15 is 90. X plus x is 2x. Subtract 90 on both sides. If we subtract 90 on both sides, we get 270. And if we divide both sides by 2, we get a beautiful 135 degree. 135 degree, that is what a measure of angle BS was looking for. Moving on to question number 4. Given this trapezoid, use the mid-segment formula to find the segment YZ. This one's pretty straightforward. All you have to do is add the top and bottom and divide by 2. So we're having 16 plus 28 divided by 2 is equal to, and again, you can use your calculator for that fraction button if you'd like to, or you can just do it in your head. 16 plus 28, that one altogether is going to be 44. 44 divided by 2 is 22. Yeah, I'm done talking. All right. Just in case you needed it. You know what? I'm putting it in there just in case you need it. It was alpha y equals enter 16 plus 28 all divided by 2, 22. And if you were like showing my work or something, you could like 44 over 2 and then 22, whatever. Let's move on. Question number 5. In the figure, what is EF? So the main idea here is all three of these sides all three of these angles, are the same. So we call this an equiangular triangle, equiangular. But equiangular directly implies that it's equilateral, meaning that if it's equiangular, it's automatically all the same sides. So because they're all the same side, we can go ahead and set up an equation that 3x plus 24 is equal to 10x plus 3. Using our little switcheroo, let's keep the 10x where it is. Let's keep that 24 where it is. We're going to go ahead and take that 3x, move it to the other side, take that positive 3, move it to the other side, and we got 24 minus 3 is 21. 10 minus 3 is 7. Divide both sides by 7, and you will get 3 is equal to x. That's not the final answer, though. It wants to know what is EF. So EF, if we measure it there, is going to be 3 multiplied by 3 plus 24. Throw that into your calculator, you get 9 plus 24 is in fact 33. Moving on to the next question. Question number 6, in the figure, what is the measure of angle J? So a few ways to approach this one, but the main idea is we call this an isosceles triangle. Isosceles because two sides are the same. because two sides are the same, this guy is an x and this guy is an x, they're both the same length. So we can go ahead and say that x plus 58 is equal to 180 because all triangles add to 180 degrees. So we could say 2x plus 58 is equal to 180. Subtract 58 on both sides of the equation. If you subtract 58 on both sides of the equation, you'll get 122. If I divide both sides by 2 from there, we'll go ahead and get 61. Please note, for an isosceles trapezoid, it's sometimes useful to just know what the algebra step is while doing it, because what you could have done on this question is you simply could have typed in, like into your calculator as a one-step method, is 180 minus the 58 and divided by 2. If I had typed that into my calculator as that fraction, you would have gotten that same 61. Here, I'll type it in just to prove it to you that we have alpha y equals enter. We had 180 minus the 58 and then divide by 2. We'll get that same 61. And that's because the algebra that we actually did, we actually subtracted 58 and then we divided by 2. So those are the two things that we did. So you could have just like kind of thrown it into a formula. Anytime you have an isosceles trapezoid where you know what is called the vertex angle, you could find the base angle by doing 180 minus the vertex angle divided by 2. All right, moving on to the next page. So number 7, what rotation about point P maps point B to point F? Find the smallest line that rotates bigger onto itself, 360 divided by the number of sides. One thing to remember is that you're always going counterclockwise. So you are going from here to here. You are not going clockwise. That would be not correct. So anyways, there are 6 parts of this. So we're going to do first 360 divided by 6, and that's going to give you 60 degrees. So each one of these is 60 degrees, and you're moving it once, twice. So because you're moving it, once and then twice up there, we would say that 60 times 2 is 120 degrees. Here we go. Question number 8, how many lines of symmetry does this figure have? So we have a little Star of David here. To do our line of symmetry, it's like anything that divides it exactly in half. So that's going to be one of them. And then you're going to have another one over here. That's 2. We got 3. We have 4. We have 5. We have 6. I don't think any other lines are going to divide it up. I think that's enough. The 1, 2, 3, 4, 5, 6. So yeah, 1, 2, 3, 4, 5, and 6. By the way, this is already repeated. That's already the same line. I don't see any other lines that could be a line of symmetry, so we can go ahead and say number 6. By the way, if you needed a definition for this line of symmetry, it means same on both sides. So like if I divide it in half, it's the same on both the left and the right. Okay, number 9. Suppose the triangle shown is reflected across this line N and then reflected across it again. Anytime you're doing a reflection twice like this, it always moves twice the distance between. So anytime you're doing this, it's twice distance between. Because it is twice the distance between, all we have to do is 32 multiplied by 2, and we're going to get 64. So it's going to be flipped over and then flipped over again. By the way, even if it was flipped over this one and then this one, it would still be moved 64, just moved in the opposite direction. So you're doing it first across N, so it's from here to here, and then after that, it's a boom all the way over there. So boom, boom, you're moving off to the right. It's a translation of 64. Even if it was, again, the other direction, if it was like over M and then over N, it would still be 64, but it would be all the way over here instead. Regardless, twice the distance between. Number 10, if ABC is reflected across the x-axis, then its image is reflected across y equals x, which single transformation moves this triangle to the other point. So the idea is you're going here and you're moving up to there. Moving up to there, if you notice, all 3 of these are rotations. Because you're only moving a single section from one quadrant to another, you've only moved 1. That's 90 degrees. By the way, if you want to kind of like prove to yourself and feel smart about yourself about why that's a 90-degree rotation, another thing you can do is kind of draw in a line from here, from letter B to letter B, to this letter B to this letter B, and you'll notice that you have a beautiful little 90-degree angle in there. please note, if it was the other way around too, if this was the A and this was the prime, you'd actually be 270 to move all the way around because you're always doing counterclockwise. Anyways, number 11, what is the slope of the line parallel? So as a reminder, we have y equals mx plus b. This one right here is our slope. This one right here is our intercept. And parallel means same slope. It also means doesn't touch, lines that don't touch, but that's the same slope. So in this case, going to be a nice and easy 1/7. That's the whole problem. Perpendicular, by the way, this means creates a right angle. Creates a right angle. However, just because it creates a right angle, what does it mean for a slope? For a slope, it means a negative reciprocal slope. Negative reciprocal. What that means, kind of in closer English, is the negative upside down. So you're going to flip that fraction upside down. So our original m was 1/8, which means that our perpendicular m is going to be the upside down and negative. So -8/1, but you actually don't need the 1 there. It's the same thing as just -8, and that is our correct answer. Moving on to our last section there. We only have one more that we have to do. Looks like we have some more of the same types of problems that we had before. And let's just kind of just hop to them. Because they are the same types of problems as before, I think I'll be doing it a little bit faster. Yeah, let's just check it out. Here we go. So let's see. We have x1, y1, x2, y2, exactly the same thing. I'm repeating it. I'm going to go ahead and be a good noodle and not actually go that fast. Squared plus, and then, so by the way, x2 minus x1 plus, and now we have our y2 minus y1 squared. That'd be a 12 and a 9. So this is yet another one that you could have done in your head if you really wanted to, or you could plug it all into your calculator. If you want to plug it into your calculator, you can. We already showed how to do that earlier on the first one. I'll do it again anyways. So we have seconds, square roots. By the way, the answer is going to be 15. I'll show you could have gotten to 15 in a second in another way. 7 minus -5 all squared plus, and then we have 1 minus 10 all squared. So there's our 15, like I was saying. However, you could have done this in your head by realizing that this distance right there, 7 plus 5, that's 12, right? So you have 12, and then 1 minus 10 is 9, but it's -9, but you're going to square it, so it's going to be on positive anyways. So you're going to have like a 9, 12, and we don't know. But if I divided by 3, I'd get a 3 and a 4, and we know we have a 3, 4, 5 triangle, so that means we can go ahead and multiply by 3 going down to get 15 as our cute, fast, correct answer for that first question in this packet. Here we go. Number 2, if A, B, if AB has these endpoints, uses midpoint formula. So just like we did last time, we're going to call this one our x1, our y1, our x2, our y2, and our x value is the first two added together. So -2 plus 8 divided by 2, that's 6 divided by 2, which is 3. After that, our y value is going to be y1, 6 plus 4, divided by 2. 6 plus 4 is 10, divided by 2 is 5. In my opinion, this one was really, really easy to think about the y value because, like, what number is in the middle of 6 and 4? Well, 5 is between 6 and 4. So I could have just kind of done that one in your head just by using that logic. Either way, 3, 5. Boom, we're done. I'm going to pause, take a drink of water. All right, let's continue finishing it up. Number 3, what is the measure of angle 2? So the measure of angle 2, just like that previous page, we have a 3x and an x here. So now it's going to be a 3x and an x. And just like before, we're going to go ahead and add these up and show that they are equal to 180 because it's a linear pair. So 3x and x is going to be 4x. Divide both sides by 4. If you do divide both sides by 4, you're going to get a beautiful little 45. So that's 45 for the x value, and that is the measure of angle 2. Nothing to even plug it into. Nice. And the measure of angle 1 is going to be 180 minus the other guy. That's going to be 135. Boom, boom, boom. We're almost done, guys. I'm telling myself that so I can power through it. Here we go. The measure of angle 5 is 130 degrees. What is the measure of angle 1? We've done a whole bunch of these. So measure of 5 and 1, these are the same. They're called corresponding angles, so that one's guaranteed to be 130. If the measure of angle 5 is equal to 130, what is the measure of angle 4? These ones add to 180, so 180 minus 130 is 50. There we go. If you want to review for yourself, which ones are alternate interiors, which ones are alternate exteriors, which ones are same side interiors, which ones are corresponding. Try to remind yourself. Question number 7. What is the length of AB? So yet again, we have to set things equal to each other. So AB and DE are the same. So this one is the same as this one. So we're going to say that 2x plus 6 is equal to 3x. I'm going to subtract 2x on both sides, and we're going to get 6 is equal to x by itself. And finally, we need to plug 6 into AB there. So 2 multiplied by 6 plus 6, and that's going to give you 18. Measure of angle D, just like before, the letter D is the same as the A, so A and D are the same. So we'll go ahead and do 4y plus 21 is equal to 6y plus 3. Solving that equation, doing our little switcheroo, so we could go ahead and say negative 3 plus 21 is equal to 6y minus 4y. Running out of room there, but 21 minus 3 is 18. 6 minus 4 is 2y. I'm still running out of room, so I'm going this way. We got 9 is equal to y. And for our final answer there, we're going to have the measure of angle D is equal to 6. We're using this equation right there. 6 times 9 plus 3. That's going to be 54 plus the 3, 57 degrees. There we go. Let's go on to question number 9 now. Here's our sum with this one of an 8-sided polygon. We call that an octagon, by the way. So we have 8 minus 2 times 180. And like I was saying before, we can just use our calculator anytime we have to do this. So just to show you one more time, we don't even need to put in the multiplication symbol. 8 minus 2 and the 8 minus 2 and the parentheses 180, and the calculator understands what you want it to do, and it tells you the correct answer is 1080. What is the value of x in the figure? We talked about this one as well. We said that these two added together is going to be the outside, so 22 plus 98 is equal to x. That's going to be 120 is equal to x. And we're on the very last page. Here we go. The very last set of problems. We're going to do it. So question number 11, if FGHI is a rectangle with GJ is equal to 8, what is FH? So remember, anytime it's a rectangle, all of these inside guys are going to be the same. So FH is the entire thing. It's 16. 8 plus 8 there to give you that 16. Given this isosceles trapezoid, what's the measure of angle F? Just like before, these two are the same. These two are the same. They add to 180. 180 minus 38, and that's going to be 142, I suppose. So that means this is 142. This is 142. This is another 38. Pausing for a second. All right. And so we get that 142 there. Yeah, that's the answer. Okay, nice. All right, number 13, using this kite to figure out AB. So just like before, there's our length AB, the 12 and the 16. So the long way of doing it, 12 squared plus 16 squared equals c squared. But let's do the fast way first. So the fast way first, we have a 12, 16, and a question mark that we don't know. So because 12 and 16 can both be divided by 4, we're going to have a 3 and a 4. And guess what? It's the same 3, 4, 5 triangle. So we can multiply by 4 and we get an answer of 20 immediately. Or we could do all the work. So if we did all the work, it'd be 144 plus 16 squared was that 196. And that's going to be c squared. And did I do that right? 144 and 196. I guess so. What is 144 plus 196? I get 16 squared. Did I do that right? That was 256. Mr. Richards, 196 is 14 squared. I am cut from the team. I knew something was wrong because it's supposed to be 400, right? Because when these two add together, it's supposed to be 400. Anyways, this is what happens when you make an hour-long video. You get bad at math right at the end. There we go. All right. Finishing it up. If ABCD is a kite, what is the measure of angle B? So just like before, we had an x here, we had an x here. Excuse me, setting up that equation, we got 72 plus x plus 118 plus x is equal to 360. X and x is 2x, 72, and 118. What is that, 190? I'm going to double check. My brain is not operable here at the end of this thing. Plus 190 equals 360. And we got 2x is equal to 360 minus the 190. And we got 170. Do 170 divided by 2, and we're going to get a beautiful 85 degrees for our x. We're finishing up 3 more questions to go. Using our mid-segment formula, how do we find this? We're just going to add them up, divide by 2. 11 plus 25 divided by 2, that's going to be 36 divided by 2, that's going to give you 18. Again, you could use your fraction button on the calculator if you want. In this figure, we have an equiangular triangle. Equiangular triangles mean that the sides are the same. 10x minus 14 is equal to 5x minus 4. Doing our little switcheroo, 10x minus 5x is equal to 14 minus 4. 10 minus 5 is 5. 14 minus 4 is 10. Both sides divided by 5, x is equal to 2, and figuring out what EF is, 5 multiplied by 2 is minus 4, and that's just going to give you 6, right? What did I write? 2. 10 minus 4 is 6. There you go. For the very last one, like I said, you could use that equation, or you can use that little trick that we did. So the equation, if you're doing it, this is these are both x's here. So we would have x plus 46 is equal to 180, or 2x plus 46 equals 180. Subtract 46 on both sides, and we'll get 134. Divide both sides by 2, and we will get 67. Or the other method again is going to be 180 minus the 46, divide by 2, and that'll get you 67. Regardless, 67 is our correct answer. And we're done with this video. Have a great rest of your day, guys, and peace out.